Alright, so hey everyone. Today I want to show how I test dead zones in games. Um, as you can see, I have my capture card showing Red Dead. This is on my Xbox. So when I'm testing console games, you need some kind of adapter that allows you to see the stick input. And I've used the Titan adapters for this. I'm currently using the TitanTwo, and this is the programming interface, and this is the device monitor. So as you can see, um, I'll bring up the game. You can see that I can see the stick input on my PC, and it's being conveyed directly to the Xbox. So I can use these values to see when movement begins happening in game. Now, if you're playing on PC, you don't need an adapter like this. You can go to Gamepad-Tester, and I don't have a gamepad plugged in, but the interface it has is very similar. It'll tell you it'll show you the stick position as well as give you the values, so you can get pretty accurate estimates using that. But the main benefit on top of being able to test on console with these adapters is that you can input values directly, so you don't actually have to manually move the stick into position. That can be kind of difficult. You can just plug in numbers and not worry about it. The way I normally test is you can see the values here are decimals, so if I move here, it's 12. This is the input, the 12.96, and it outputs 12.96. There's nothing changed. But I mostly test with whole numbers, and I have a simple script to do that. A lot of this is miscellaneous. But you can see now 14.02 is rounded down to 14. And I do this one because I started testing with the Titan 1, which only had a resolution of -100 to 100. So that's this kind of tradition. But this also allows me to move pretty accurately into the position. So if I want, 35, 31, I can physically do that myself. Now, cutting off the decimals does reduce the precision, so at least 1% of error comes from this. If the dead zone is 30%, I won't see movement until 31. So when normally you should see it at 30.01 or whatever. But there are some ways to kind of minimize that a little bit, or at least you'll see when testing. But that definitely doesn't appear in videos that I've demonstrated, and generally the size is pretty accurate. But I'm going to show, just jump into it. So I'm going to show both the test, but also how I draw the lines for the graphs once these points are plotted. But this will be a long video, and probably pretty boring. So let's not waste too much more time. So the first ones I try to look at are the cardinal directions. So here I'm going to the left as perfectly as I can, and you can see that 0, 39, there was nothing, and at -40, 0, there was movement. So now I'm just going to verify that that occurs the same over here. So at 40 it's moving. If I pull back to 0, 39, nothing's happening. So that's symmetrical there. 39 up, nothing, and 40 movement. Nothing, and movement. So I plot all these on Desmos, the graphing calculator. So normally I draw, this is the equation of a circle. So I just draw this to get the shape, the general shape of the stick range I'm going to be using. I add a folder. I'm going to call this camera. And I just plot those points. So we found 0.4, 0, 0, 0.4, 0.4. So we can see that this is symmetrical. That's very helpful. I do most of the detailed points on one quadrant. The quadrant doesn't matter. It's just I test all four of these points just to make sure it's symmetrical. If one is offset, then I will have to test more points to make sure that to better see the shape. But since it is symmetrical, I can just focus on this. So the next point I test is the first diagonal I see. So I move the stick diagonally and see when I start seeing movement. So there you see 35, 35, there was nothing, and 35, 36, there was. So plot that. All right, and this diagonal point is pretty important because this already tells us that it is not a completely square dead zone. If it were, we should see movement at 40, 40, but this is a little short of that. This also tells us it's not a circular dead zone because if you imagine a circle, we'll be drawing it later, but this is too far out for it to be a circular dead zone. So we already have a rough idea of what the shape probably is, but we're going to throw more points at it. So I'm going to just move over to 1 and then look at 40 and then move up 1 and then go over to 40. So go over to 10, 40. So there was movement there. No movement. And then movement. So plot that. Right. And do the next one at 2. So move over 2 and see where movement starts, up 2 and see where movement starts. And sometimes it's a little difficult for me to get the exact position, but nothing at 39 and 40 at 2. And 40 at 2. Now I'm using to draw this graph between -1 and 1, and the Titan range is from -100 to 100. So the range doesn't matter. I just prefer to draw -1 to 1 if someone was plotting. If you're using Gamepad-Tester, this uses -1 to 1. It really doesn't matter. As long as you're consistent, the shape is going to be identical. But anyway, the shape is already becoming pretty clear, and this seems most likely to be a rounded square dead zone. So we can just keep throwing numbers out. We could test 30 and see what that is. But what I like to do instead is, since this is 40 all the way for these 3 points, I'm going to look for when the first instance of 39 occurs, just to see when that first change is. But again, you're going to see the trend really no matter what points you choose to look at. But if I move over to say 39 and just keep moving up until I start seeing movement. Okay, well that's occurring at 29, so 29 and 39, and verify it over here. So move up to 39 and move over to 29, and you can see that that's the same there. So plot that. All right, and the shape is pretty clear, but I'll do one more point in between, and I'll choose say 32. This is a pretty nice in between both these points. So look at where 32 and another point. So horizontally up to 32 and just keep moving up until I see something. Okay, well 32 and 38 seems to be it. So now move up 32 and then over 38. And there's movement there as well. So we have a pretty clear shape for what the dead zone looks like. So it is a rounded square dead zone. And this is the first part of what I look for. So I look for exiting the core dead zone, so any movement. Next, I'll look for any restricted diagonal movement. And lastly, I'll look for any acceleration jump. So for restricted diagonal movement, looking up actually around, I start looking for the horizontal restriction. And to do this, I'll use something where I can look up. I cap the view like this, and this tower is a good reference point. And I'll move the stick. As you can see, there is a restricted movement. There's no horizontal movement occurring. So I'll cap the view like this and just slowly slide the stick over until I start seeing diagonal movement occur. And you can see that that is quite abrupt. So it's pretty clear. Let's pull off. So 47 and 98 had nothing. And move a little over there. And 47 and 97 did. So we have diagonal movement occurring there. I normally create another line for these separate thresholds. So 47, 97, not much. And then I'll just move up the stick to 80 and then see where diagonal movement occurs there. So move up to 80. Okay, and that seems to be around here somewhere. So if I can just keep it at 80. Nothing at 40, nothing at 41, but something at 42. So 42 and 80 is where that's occurring. Then I'll do 0.6. Oops, no, that's wrong. There we go. Yeah. Okay, so we're around here. So we're going to try to bring it down to 60. Okay, so nothing at 35. It was moving at 36, but let's just try to verify that. So it's 36 and 60. And nothing at 35 and 60. And 36 and 60. Now the specific points you look at don't matter much. I just choose 1, 80, 60 just to have clear increments, but the exact numbers don't matter. I'll do one more, like at 41, just to test where the diagonal movement is there, just past the dead zone. As you can see, I'm having trouble staying at 41. Sometimes I'm more precise than not. So 28 and 41, there's nothing. And if I try to move to 29, you can see that at 29 and 41, there is movement. Okay. And as we can see, it's a pretty straight line. So the trend is very obvious just with these points. Now, testing around the vertical axis is a little different, but the exact same. Because we found these points, we know really what we should expect to see over here. So that saves a bit of time. Because this is both This can be both more reliable, but also more difficult, because what I'll do is cap the view down like this, and when I'm looking for diagonal movement and passing a threshold, if diagonal movement occurred, then I can center the stick and just point it down, and if there was movement downward, that means that diagonal movement was occurring. There was vertical movement happening. And if there wasn't, if I say put it this position and release it and push down, and nothing happened, that means there was no diagonal movement. So to try to find the border, we found movement at about 47. So let's look at this. 47 and 9947. Let's center it. And there was nothing there. So let's try 48 now. And well, that's pretty dramatic. We're now pointing at the ceiling, but there was clear diagonal movement there at 148. So 1 and 0.48. And you can see that this is -1 and 48, and this is -47 and 97. And the reason for these different values is just my stick leans a little further in this direction than this direction. These ones will be more consistent. So I'm going to aim for 80 and 42. So I'm going to first try to check 80 and 41 to verify there's no movement at that. So move the stick over to 80 and move up to 41. Okay, and I moved to 81, that's not what I wanted, but okay, well I moved to 42, so I might as well do that test. So, and then I'll center it, and there was diagonal movement there. With this, unfortunately, if you do bleed over, that can mess up your test, because unlike when you're testing this way, it doesn't really matter if you see movement. You can just pull back and keep going. You can just spin infinitely. But if I did trigger movement accidentally, then that'll mess up the test, and I can't test if there isn't diagonal movement if there was at a different value. So I have to retest or look for that 41 value to make sure that there wasn't movement there. And you see I went to 79, and that can be bad because based on the slope there could be movement, so we'll see if that messed up things. So if I tried to go 80, 41, and there was nothing, so that deviation didn't affect anything, but we've now confirmed that it was the same as the horizontal restriction. Then we'll do 60, we'll look for 60 and 35. And I just normally let it stay for a few seconds to see if there is subtle movement, but you can see that there wasn't any. Go back to 60 and aim for 36. And there was, so exactly the same. I won't bother testing this because we can kind of assume that's the exact same. The one real benefit with this method over when you're using this, as we saw here, this is very abrupt, and this is actually way more abrupt than it should be. This kind of implies that like diagonal movement should start very subtly once you pass this threshold. This is probably not scaled properly, so you're just losing subtle angles with this implementation. But some games have a very subtle diagonal movement. which can be very difficult to see. It could just be like, it's moving pixels at a time. So it's hard to see gradual movements. However, if you do this method and just keep testing points, this can make it so that you can just leave it, just hold a point for a while, and even if there's a tiny bit of movement, this may be more obvious. So like if there was, just nudge over, holding it for 5 seconds, that could be more apparent than just some pixel drift using this method. So this is normally the easiest to do, but this can be good if the diagonal movement's too subtle to easily notice. But the last thing I test is any acceleration jumps. So I'll just slowly move the stick and try to look for any noticeable jumps in acceleration. Now, this is a pretty big increase in acceleration, but if I just try to move, a single percent lower at a time, 98, 97, 95, I can't notice a clear jump. So it could be that this curve, just steeps up very quickly, but it's not a formal jump like we see in some other games. I'll try to show how I test curves in another video. That can definitely be more accurate than just roughly testing like this. But for this, I'll just say there's no acceleration jump, at least one that I can easily see, so I just won't test for it. So for now, the camera dead zone is done. I just want to show a bit of how I would test movement. Like for the basic movement, this is exactly the same. You just move until you see something happen. So try to keep this horizontally centered and move up until I see start walking forward. So 31 seems to be that threshold. Then I won't actually plot these points, but if I try moving diagonally, you can see that it seems like 29, 29 is the first diagonal, but we got 31 for cardinal direction. So this too is probably a rounded square shape, because if we move diagonally and it was 31, 31, it'd be square, but that's much too far to be a circular dead zone. Now the big thing with movement is testing for diagonal movement. This can be kind of difficult because you don't have, nice references. You can't see, a tree moving in the background. So for third-person games, what I'll often do is try to find some reference, and let's use this tuft of grass as reference. And what I'll try to do is, align myself with it, and I'll try moving perfectly forward, and then try moving perfectly backwards. And ideally, if you're moving perfectly forward and back, then you would land right back on the same exact tuft of grass or whatever reference point you're using. As you can see here, there is some camera following, so this changes your direction and completely bungles that test. What it is useful and what's very common, exclusively common when testing first-person shooters, is this, at least the dead zone size, seems to be exactly the same shape for when you're aiming your weapon. So just to demonstrate the diagonal, it's the same. So we can use this, and what I try to do is line myself up with some reference point, and I'll do this at the side of this post. And this is something that's really useful, being able to input values with this adapter, because I don't exactly have the precision for this. But actually I'll just demonstrate it crudely, because now if we move backwards, and this is actually a failing that's quite obvious right here, is ideally if we have aligned right here. If we move backwards, you can see that it's tracing that pretty nicely. And if I move forward, you can see that it's traced it pretty nicely. So really no diagonal movement occurred. However, you can see that if I'm moving back and forth, it kind of jutted, and games with sort of quote unquote like realistic movement will have this. So for example, if I'm moving and switch directions, you can see that he like does an arc, and this will skew your movement, and that does still seem to occur here. So that really muddies these tests a bit, and we really want to look for more dramatic movements in that. Like if I move back like this, you can see he lurched over to the left and immediately messed that reference up. But what I'll do here is I'll move to here, and if you set this, so say is, let's try like 23. So this is just inputting, so I'll be moving backwards but horizontally 23 over. So if I play this, I'm not moving the stick at all. The script is now just running, moving it. And then I'll stop, and I'll flip directions and move up. And you can see that there's no meaningful diagonal movement occurring. I'll just slowly increment this. Let's do 26. That's a bit more of a jump than I normally do testing, but we'll try to speed this up. We'll run this. I'm moving backwards just a little bit more horizontally, and you can see that he is drifting away from this quite regularly. And move forward. And you can see that there's pretty clear diagonal movement. He is well beyond the original reference point. And the closer you get to the dead zone, so I was moving, at 50. Sorry, that's the right stick. I was moving at 50. If you're moving at 100, 1 point difference isn't going to make too much of a difference, but 1 point difference closer to the center is going to make a larger angle, so those angles are going to be dramatic. If you can pick a point like right around the dead zone, diagonal movement is going to be far more obvious. So of course I was using the script for that. That's not helpful for people who are using Gamepad-Tester to try to test this. So if I realign myself and move back very slowly and move a little over, you can see that nothing's happening, but if I move to 26, then something is. So and then we can do that again a little more precisely, so because I jumped to about 23 to 26%, but 24%, about nothing, and then 26%, I mean, that was my lack of precision. But if it's actually 25%, then it's still, it's only 1% off. But that's how you can generally gauge where diagonal movement is occurring. And of course, it's nicer also moving slow. There's only like really 2 movement speeds when you have your gun out. And this, you have jogging and then just walking. And if you're using slower movement speeds, it's much easier because you don't have to risk running into stuff with these tests, and you get more dramatic angles, so you can more easily see that threshold right around the dead zone. So yeah, just use any kind of tall and hopefully perfectly vertical line as your reference, because it's a pretty good metric for that. One little quirk Red Dead has compared to a lot of other games is for some reason while you have your gun readied, you do have 2 movement speeds. You got your walking speed and then a jogging speed. but this doesn't apply when you're just moving around normally. So you can see that if I let go, he's still jogging, but after he puts it away, he's forced to go back into walk, and it's there's no different speed gradient based on stick movement. So that's kind of strange. And if in my test, I just made sure to say that this run threshold is only relevant while the gun's readied, and not relevant for normal movement, even though they share the same core dead zone. But anyway, I mean, that about covers it. A quick addition, since Red Dead doesn't have a sprint threshold. There are games that have dedicated sprint buttons, but you have to move the stick past certain thresholds before they work. So as you can see here, I can try sprinting, but my stick isn't far enough. But if I move the stick further, then you're allowed to start sprinting. So trying to find that threshold, it's useful to have wide open space, just so you've got some time, so you don't you can change your course, or so you don't fall off ledges or run into traps or whatever the game may have. Depending on the game, you could run into a wall, and you can see that it's inconsistently trying to stop me from sprinting. But if you say move into corners like this, you can stay sprinting, see the animation for it, and do the test like this, so you don't have to worry about where the character's going, and just focus on the input. So, and then to test this, you just slowly move forward until you are allowed to start sprinting. So, I can't sprint, and I can about 80-ish. There are single and double threshold sprint thresholds, and what that means is there are some games with two, meaning that there's a threshold where you begin to sprint, and then you have to pull back, like while you're sprinting, you have to move the stick further back before you're allowed to stop. In this case, right here is just a single threshold. You can see that I can't sprint, I can sprint, and then I can't sprint again. So the threshold when you're allowed to sprint and when you're forced to stop are the same. So in these cases, this ends up being useful, because what you can do is just push the stick fully, and then instead of testing values upwards, you can just start sprinting and then pull back, and see that that was 80. And since the threshold is the same for either direction, that's your threshold. So if we do this about 25-ish, I'm not going to do this too precisely, but you see it's about 26 or 25, and 25, 75 was the point for that. 50 and 51 and about 62 was the point for that. Then slide along here. I slide along the edge of the stick just to find the angular range, like how far out does this work. And you can see that this triggers, right on this diagonal line too. If you're plotting all these, you'd end up finding that it's a circular threshold with straight lines at the end, and that means that if your stick is within 90 degrees forward and past a certain point, you're allowed to start sprinting. Now, this game does have an auto sprint option, and unsurprisingly, that automatically sprints for you. The manual did that for whatever reason, but and we can see here that previously, we were allowed to start sprinting at 80, but we're not sprinting now, and we don't start sprinting until about 94, but we have to move back to 80 or less to stop sprinting. And if we move to say 25, we start sprinting about 92, and we stop sprinting about 75. So you can see that there's a threshold for when we're allowed to start sprinting, and then when we can stop. You may remember that these 2 points ended up being the same for the manual threshold, and this still applies here. And you can see that that's we can manually sprint in this range. Here, if you're drawing this graph, you'd probably want to define, this lower threshold is for, the manual sprint option, and this 2-step threshold is for the auto sprint option. But you could just keep testing this in the same way. So you just move over here, see when you can start sprinting there. And you'll end up finding, if you tested all those points, that the thresholds are very similar. It's just the auto sprint threshold has a higher threshold than the manual one. Now, this can be kind of obnoxious depending on the shape of the threshold. Here it's pretty consistent, but depending on the game, this can be a little obnoxious. Anyway, this was just an addition. Back to Red Dead. We could look at, say, whoops, that's not what, the map cursor. Again, I'm not going to plot any of these points, but if I, say, went back and just put that back on to put those values a little lower, we could test this in exactly the same way. Just move this and look for when movement occurs. So you can see movement is occurring with the cursor at 31 and not 30. So there's movement there. Let's check the diagonal. Okay, it's at 22.22, but let's try 21. There's no movement, and 22.22. So if we were to plot this, this is actually circular. I might show that on screen, but you can actually see that there is no restricted diagonal movement. If I just pass right over this axis, you can see that it's slowly moving to the left, and then slowly moving to the right. So actually the map cursor has the best controls in this game. Movement and the camera are don't compare to the map cursor. But let's get back to here. So we have finished this camera, this camera dead zone points. And if we were to test the movement and map cursor dead zone thoroughly, we'd get, the same shape there, or not the same shape, but the shapes would make themselves obvious there. But how do we draw the lines now? For the most part, this graph is obvious. You can see the trend. If we left it as is, this would be perfectly functional. But drawing the lines actually just requires a few different functions. If a lot of people have been out of math class for years, but the math you need is actually relatively basic. It's just like graphing math, and while it may look complicated, it's actually pretty simple. I might do a terrible job teaching this, but I'll try to do my best. So I only use 3 to 4 functions. So I use circles, I use straight lines and diagonal lines to draw everything. And all I do is just move them around and change the size of them. So for example, I drew a circle just to make the just the stick boundary. So this is the equation of a circle, and it's technically whatever the radius squared, but anything 1 to any power is still 1. And you can see that right here. So if you're writing this in Desmos, use this caret to do exponents. So like if I do x shift 6, that gives me an exponent, and that's x squared. So I had these prepared. So if I use, this is a circle. This is the equation for a circle, and c is just the size. So if I change the size, it changes the size of the circle. Now, I have a modified version that I use, and this is the same exact thing, but instead of squared being the exponent being 2, it's variable. And if we say, let me just do 0 and, oops, 1 and get rid of that. Now you can see that if you just put any exponent, many of them won't work. So I found something that worked, 1.04, and in steps of 0.08 gets range. I didn't figure this out. I just threw numbers at it until it worked. But these increments are nice and round, and what this does is kind of change this from a diamond shape to around a square shape, and I can increase this exponent to any amount I want. And the usefulness is if I'm trying to draw a curve, like we're going to try doing here, this specific one isn't too relevant, but you can change the size and the curve, and I can use specific parts of this to draw certain curves. So that's what we're going to use. We're going to use just not the one with that exponent, but just the normal circle to draw this. Oh, and actually, sorry, before I do that, there's one minor deviate. Actually, no, I'll get to that in a bit. So we have a circle here, and the circle matches this arch right here. So that's very useful. And you know, if we just change the size, this obviously doesn't work here. We just kind of want a circle in this position. What we can do is just offset the circle, so we can move this, called a transformation. So you can see that it's centered right at 0. We could have this move so that it's centered somewhere over here so that it matches this a little better. And to do that, we can just put parentheses around this guy and have, if we say add 0.1, this actually changes the vertical component. The y is the vertical for a function and x is the horizontal. So if we isolate them, see if we, and this is kind of backwards, so if we subtract it, it goes up. If we add it, it goes down. So we moved it up 0.1, or moved it down 0.1, now 0.2, 0.3, 0.5, move it up 0.5. So we can do that, and if we wanted to move it over, we can move it plus 0.2, and now it's over 0.2. So we can use this to move these things around. And as you can see, I have a little function right over here, and just the offset. So this is variable. So you can see that I just put these custom values in here that, you know, we want to kind of move this from the center up here and then kind of change the size, oops, so that it matches pretty neatly up to that. So to try to demonstrate that, let's draw a circle. Squared is equal to, let's just say 0.1. We can mess with the size a bit. And we want to move it over kind of diagonally up to a certain point. Something that helps, if you're familiar, is a rounded square dead zone is a circular dead zone that's sitting on top of an axial dead zone. And this axial dead zone is sort of a cross shape, and where the corner of the square ends is kind of where the center of the circle is. So we can kind of just imagine what that is and where we believe that this would start curving out. You see how it's straight and where it's starting to curve. So let's just pick, say, like 0.25. So we have our circle equation here. If we isolate the x and y's, we want to move it over 0.25, and this is a little backwards, so if we move it left, we say plus 0.25, and if we move it up, we say minus 0.25. Okay, so we now have the center right here. then we just edit the size. So 0.1, a little small, 2, 3, 4, 5, 6. Well, 6 is a little big. So 4, what about 5, 6? Let's zooming in. This goes a little over the point we found, so that means that would be making the dead zone a little larger. And 14.5 seems like it fits this pretty neatly. I tend to bias towards the lowest dead zone value I find, just to kind of minimize any error, not to make the dead zone larger than I think. But you can see that this shape matches this pretty neatly. But we don't want to draw the full thing. So what we can do is tell this to only draw part of this. Like we only want to draw from here to here. So what we can do is in Desmos, you can say bring out these curly brackets, and since x is the variable controlling the horizontal, you can say that you only want to show this horizontally from here over. And here you can see that the horizontal position is negative 0.25, so you want the horizontal position to be less than that. So x is less than negative 0.25. So there, we're only showing half of this circle, but we're still showing this portion. And in the same way, y is the vertical position, and we want to show only what's above this. So this is also at 25, and we'll do the same exact thing. So y is over 25, and there we have a quarter circle drawing that portion of the graph pretty neatly. Now we just do the same for the other three sides, but we don't actually have to do a whole lot more work to get that. We don't have to write this over and over again. I'll erase the bounds we wrote, so this just creates a new circle where the other one was. So the circle was originally centered, and we moved it over 25 and then up 25. Well, now let's try moving it over here. So we originally moved it horizontally this way. So let's instead move it this way. But all we would have to do is just change the sign from plus to minus, because instead of moving to the left, we just move to the right. And since we copy and pasted, it's already vertically in the position. And in the same way, we can bring these curly braces, and this time it's a little differently. Horizontally, we want it to show only what's on this side. So x should be greater than 25 at this point, 0.25, and you see we're showing that. And y, similarly, actually doesn't change at all, so we still want that to be y greater than 0.25, and then we have that corner. There's actually a slightly bit easier way that further allows us to copy and paste this. If we copy paste this again, now of course it vanished completely, because copy pasting this one is saying that only show basically horizontally over here and vertically over here, but our circle is still over here. What we can do is, instead of saying x is greater than 0.25 to that, when we had this over here, we were saying x is less than negative 0.25. You can actually, based on how inequalities work, you can actually just throw a negative in there, and this automatically flips these signs and the inequality the other way, and all you have to do is just add a sign to have it flip that way. So that's an even shorter way of doing this. So again, let's copy and paste this first one and here. So we created, we just copied this part, and we have the other 3/4 of the circle still hidden. So we have one right here, and now let's move this down here. So we want to move this vertically, so we're just going to change the y component. So we find the y and offset it the other way. So instead of minusing, we're we're adding, and this actually has jumped down here, but we can't see it because we have our bounds saying that y can only be shown when above up here. So, but we just add a minus sign, and this flips it and tells it to show y when it's down here. So let's again copy the top one. Again, another circle with the bounds over here, and instead of moving it up this way, both up and over this way, we instead want it to go the exact opposite way. So we change both the horizontal and vertical components. Now our circle is over here, but our bounds are still up here, so we flip the signs for both of them. Add a negative, and that's done. So if we can set up this right, the rest is just copy paste and flipping signs. The next function I use is just lines, and if you say x is equal to a number, it will create a perfectly vertical line at that position. So I said it's equal to 0.5, it got 0.5 and created a perfect line there. So I want to first create a line right here, so I'm going to say negative 0.4. So this lines up with the points, but as you can see, it doesn't line up with the circle that we matched up here. And this is because, as I said, I test with single % increments. So if the dead zone, say, is 35, then there wouldn't be any movement if you're right on top of the dead zone. But the next point I would have access to is 40, where there was movement. But if the dead zone was truly 39%, you would see movement at 39.1%. So as we can see here, this may be closer to the truer dead zone, and we'll just line it up with this. So instead of using 40, this is 39.5, and now you see that's flush. So so this is error, but error that's being mitigated a bit because we found some smaller diagonal points that led us probably closer to the truer dead zone. So now you can see that this line, goes vertically to infinity, and we don't want that. So similar to what we did with the circle, is we only want to show part of it. And see the ends of these, go up to 25. So what we do is say this is vertical. We only want to show this vertically from 25 to negative 25. So what we'll say is bring up the curly braces. Y is less than 0.25. And so it's only showing anything beneath that. But we want y to be over negative 0.25. So this shows what's above it. So we have a line just right there. Then again, we can just copy paste this, and we drew a line straight up at this point over here, that negative 395. But now we want a line over here, and all we have to do is remove this negative sign, and it draws it right over here. And since we copy pasted the bounds over here, they're the same, so we don't have to do anything else for that. For these horizontal lines, it's the same exact, but instead of using x is equal, we use y is equal to 0.395. If you say y is equal to something, you get a perfectly horizontal line. And the bounds are similar, but instead of using y here, we're going to use x because we want the horizontal range from here to here. So we want x to be less than 0.25, but then greater than negative 0.25. And as you can see, these are identical. You could have just copy pasted this and then just switch the x's for the y's, and it would automatically flip that for you. And then again, we copy and paste this one, and then throw a negative to just flip it right over the axis. And then we're done drawing the central dead zone. Now for diagonal lines, I'll use the equation of the line, which is y is equal to x. So, oh yeah. So y is equal to x is creates a line that moves diagonally, and it moves at a slope of 1 by default. And you can see that if you multiply it by a number, which I have here, I've just added a variable for it, you can see that it changes the slope and it pivots around 0. So you can input whatever you want. So, you know, if I put the slope to very slow, it's almost completely horizontal. And if you put it high, you can, of course, put it much higher. It's quite vertical. So I use this to try to align. I'm going to use this to try to align with this. And if you throw a negative in here, it just flips the direction of the slope. So this will be useful when trying to align this with this line. As you can see, that I'll try to adjust this to match that. But in the same way that we were able to offset the circle up into these corners, we can do that with lines. So for example, if I isolate the x in parentheses and say plus 0.25, or actually it's technically minus if I want it to move up, and then plus 0.25 if I want it to move over, you can see now that it's over in that position. And if I move this, you can see that it's much better aligned. So all we have to do is mess with these values to get pretty close to what we want. So I'm going to hide that and create a new line. So y is equal to x. So we have the function here. We want it the other way. So I'm going to put a negative, and I'm going to offset it 0.25, just like we did for the 0.25, the circle. And if we multiply it by a number, we can get something close. So that's 1, 2, 3, 4. 4 seems a little steep. 3 seems pretty close, but actually, as you can see, it's lining up pretty close, but a little farther to the left. So that could mean our pivot point's a little off. So let's, instead of being at 25, we can pull it back to, say, 20, or 22. Let's just pick 23 and 23 and see how that looks. It looks pretty good. It's now not quite steep enough. As you can see that it's a little under that, but we can make this a little steeper. What's 3.2? That might be too steep. Or 3.3, 3.2. Maybe we can make it a little, and that's pretty good. You know, that's overlapping this node. So that's lined up pretty neatly there. So now what we want to do is just find, or to only show from here to here. And this, you know, gives us this nice intersections. So we can see where this intersects the line, and the second number is the vertical position. We're trying to, you know, just use this vertically from here to here. So we want to say y is under that 0.8957. So y is under the 0.8957, and see that's nicely connected to that circle now. And but we want it vertically to be over the 0.3914. So y is greater than 0.3914. And there we go. We have a nice line right there. So again, like what we've been doing, we just copy paste this whole thing, and we want, since it's symmetric, or we imagine it's symmetric, we want this line over here. Well, it's centered at 2323, and we want it over here. Well, vertically it's in the right place, but we'd want this moved horizontally over there. So similar to the camera, we find the X, since that's the horizontal one, and we just change, or not the camera, the circle. We just flip the X offset. Now you can see that it's facing in the wrong direction, but if we flip the sign of our slope, we get the right direction, and that works pretty good. Then we paste the first guy again. This creates another line where the first one is, and let's bring it down to the bottom. So we're changing the vertical position from this. So we find where the Y is, switch this to a plus, and the reason why it's still displaying up here is because we're showing the vertical region from here to here. We want it to show here to here, so like what we did with the circle, is we just find the Y position and throw a negative, and then it flips it over here. But it's flipped the wrong way. We want it this way, which means we just change the sign, and then that's done. Copy it again, copy this first guy again, and again it's centered over here, so we want to change both the offset for the horizontal and the vertical to get it down here. So we find both the X and the Y and switch those pluses and minuses around. Again, it's at the bottom, so we want to show it down here. So we just flip the sign and we've got it. So we have the horizontal restriction taken care of. Now for the vertical restriction. So here you can see that the slope is more shallow than what's here, but this is actually still pretty straightforward, because it turns out the reciprocal, meaning any kind of number, 1 divided by whatever number, the reciprocal of the slope, in this case this is the slope, the 3.1, that's how steep this is, gives us this line. So for example, we have 0.31. If we do 1 divided by 0.31, or sorry, 3.1, we can see that this is matching that. However, you can see that it's being cut here, and that the reason for that is because we're still using Y, so we're saying draw from here up to here. Well, instead we want it to be horizontally from here to here, so we're going to change this to X, but this is a little backwards now, so it might be actually easier just to undo this and just start from scratch from here, where we have this horizontally, and we want to say X is greater than, so show everything horizontally from that negative 8957. So X is greater than negative 0.8957, and you can see that we're showing everything from there on out. But X is also smaller than that 0.3914. Now I've kind of done this a little backwards. But you can, have these inequalities go either way, as long as you're consistent on the order. So, so as you can see, we're done here. And again, now we just start the copy paste. So let's copy this, paste it, and I just copied a brand new line. Now I want to draw the line that's going this way. So we're just gonna, again, it's centered right here. So we want to just move it horizontally over here. And of course it is connecting there, but it's only drawing on this side, so we want to flip where it's drawing. We just find the X bounding, flip the sign, and we can see that it's facing the wrong way. So we change this the sign on the slope, and it's exactly the way we want it. Again, copy paste the first one, and the next one we can do is again center right here, and we want to change it over here. The vertical position is what's changed, so we find the Y, change the minus for a plus. It's facing the wrong way, so we switch the sign on the sign of the slope, and it's exactly where we want it. Fourth time, so we have it centered here. We want to move horizontally and then vertically down, so we change both the X and Y signs. Then you can see that it's still being drawn on this side, and we want it drawn over here, so we flip the bounds that it's drawn on, and that's already aligned. So we're done with drawing the camera. So we have nice clean lines, and yeah, that's it. So a lot of this looks kind of complicated, and but hopefully I've helped a little bit to clarify it. But once you get one quadrant, then the rest is just copy paste. You just copy it all around, and that's all you need to do. So I just use these three functions, circles or the variant, perfectly straight lines, and diagonal lines, and just throw numbers at them until it works. Just shift them around, and until something works. The only thing I didn't really show is for circles. There is a formal equation for an oval. So let's go back here, or an ellipse, I guess is specifically the term for it. If you divide this by, say, 0.5, this will change the, I think it'll be simpler not to worry about the formal equation for ellipse, but if you multiply the y component of the circle by numbers larger than 1, by numbers larger than 1, it will shrink it. If you multiply it by numbers smaller than 1, it will vertically expand it. The specific equation for the ellipse is good for this function, because as you can see, again, using the exponent for this equation lets you get a little more square or rounded square shapes. And if you change, let's say, this to 0.8, but change the exponent, you can see that the vertical component changes when you adjust this. But if you use the formal equation, which has you by, like, say, 8, has you divide by it, and if you're dividing by it, this does change how you're oops, that's a little too big. This grows pretty quick. You can see that this doesn't affect the position, so this can be more reliable. But if you already have the curve you want, it doesn't really matter if you're dividing it like this, as in the more formal ellipse, or just throwing numbers at it to adjust the scale. You'll just have to mess with that a little bit, and I'll show that here. So again, what we did in this video is draw Red Dead's camera dead zone, but I will show I've been working on Nioh and its PC camera dead zone. So I haven't finished it, as you can see. if you're playing with an Xbox controller, movement is very straightforward. You just draw a few circles, nothing exciting. Same with the map cursor, just a simple circle. There's no, and you can see this is how I drew it here. This equation of the circle at this size. Nothing special there. The camera, I just drew straight lines. So like what I demonstrated for drawing these, as you can see right here. The only thing special here is the bounds. As you can see, the square root of 1 minus x squared. This is the equation of a circle. This is saying have the bounds under the equation, under the circle, and this is something that I just remember at this point. What usefulness is, this is saying that normally, like we did over here, we would look at the intersection. Let me see if I can find that point. You can see here, this is the line that we drew over here. We would look at this and see the y value, the 8 point, or the 0.8957. So we would look for that. But this automatically says be under this, and so I don't have to actually find that. It just explicitly says that. For example, if I did x is equal to negative 0.1, it's drawing a line there, and I can do y is less than the square root of 1 minus x squared, and you can see that that automatically capped it within this range. And if I do 0.3, 0.5, if I change this, it's still capped within this circle. So that's very convenient, so I don't have to do that. So that looks complicated, but you know, once you know that works that way, it's just a matter of copy pasting things over and over and over. But the camera, this is pretty simple, just 4 different lines and all copy paste. This is the most complicated one, but as you can see, let's look at this guy right here. So that is this line over here, and if we remove the restriction, I'm saying we can see what the actual oval looks like, what I used to make this curve. So I just moved a circle basically into this place, and I just extended this down. I just threw numbers at it. So like 0.5 is not enough. Oops, keep doing that. 0.6, like 3, 0.1, that's too far, 0.2, and I had messed with the exponent. You know, this makes this into a rounded square or a sharper, and you can see that it's moving the vertical position, unlike a proper ellipse. So like if I adjusted this so that it was like that, I would have to go back up and then just finagle it there. So I would do this and see that it's over those lines, and be like, okay, well, I want it to be a little wider, so if I put it that way, I'd come back and okay, so maybe 19, that might be a little big, 5, 4, 3, and you know, that could work well enough for this line. Of course, you see this one's a few points out, but I take some liberties with, you know, how I draw it with some weird shapes like this. But so you can see this is just an oval that I drew, and then I just said, you know, I want to hide most of this, so I'm going to say hide the vertical portion so that it's under 1. So y should be less than 1, and that hid this, and hide it so that it's only drawing it from here over. So I'll just pick like a point, let's say what this one is, 22. So x is greater, oops, well, that's backwards, greater than negative 0.22, and that's only showing that portion of the circle. So this is how I draw, even more complicated graphs. It's just a combination of circles, straight lines, and diagonal lines. So you can see this. A couple different games now. I'm gonna have to start testing more on PC. Have different controls between Xbox and PlayStation controllers. So as you can see here, when I tested on movement for the Xbox controller, it was perfectly circular, but with the PlayStation controller, it's cog shape, and you can actually see a few different things, like this circle is actually a perfect circle. So let's see if I can see where that is. Where is that one? Okay. So I drew 4 of these, and I didn't have to offset this because it's perfectly in the center. You can see that that draws a perfect circle, but I only wanted it in, from this range. So I added these bounds. Oops, there we go. So it only showed it from here to here, and I just copied the same exact circle different times and just changed the bounds. So show only this part of it, then show only this part of it, show only this part of it, and show only this part of it. Just to get all 4 of these thresholds. For the inner dead zone, this is actually circular as well. You can see that up here. So if I took away these bounds, you can see that this is circular. But I could have drawn 4 like this, but I could save some time if I capped it vertically. So it just cut it here, then that would take care of both sides of this. And you can see, oh, why am I doing that? There we go. See, if I bound it here from y is smaller than about 30, and you can see there it's about 30.6 down to 24. So if it's drawing vertically here, that's what we're left with. And then I just use straight lines for this. So you can see the straight line. I've got this, the equation of the circle. So this just tells it to be under the circle threshold. And this is actually another circle threshold. This is the size of this circle. So it's telling it to be above this circle, but below this circle. So I didn't have to find the intersection of that. That just automatically worked that way. I'm sorry, this is all like sounds complicated, but once people get, man, I cannot spell. But you can see here, this is another very simple one, the same as the camera there. And the aiming that's on here is just straight lines. So straight lines just with specific bounds. So for this one, it's draw a straight line at 24 and say it's from the bottom of this circle up to this point here, negative 0.24. So that's all it really takes to draw these things. And when I'm done with these graphs, I just take these nodes, change color to be black, hide the dots, bold the lines, get rid of this, and then take this image into some editing program and just fill in the colors. So blue for restricted angles, green for diagonals, and red for the dead zone. The colors don't matter at all. That's just what I've been using, and that's it. So hopefully this has been somewhat interesting, but it is kind of a tedious process. Sometimes it goes very fast, sometimes it goes very slow. Something like Red Dead's dead zone can actually move quite fast. Something like Nioh's aiming dead zone is kind of obnoxious to draw out. And some games with perfectly circular, if you get a perfectly circular threshold, this will take nothing. It's you know, as you can see here, it's two nice circle equations and you're done drawing the graph. So that's all that takes. But yeah, that covers things. I've been rambling enough. Thanks for watching, and everyone, have a good rest of your day.